Imagine for a moment that you are standing on a pier, looking out over a vast midnight ocean. You can see the white foam of the breaking waves, the shimmering reflection of the moon on the surface, and perhaps the distant flickering lights of a passing ship. To your eyes, these bright spots are the totality of the sea. But beneath that thin skin of light lies miles of crushing pressure, silent currents, and strange creatures, a massive hidden volume that defines the ocean's behavior and keeps the world in balance. This is exactly how we perceive our universe. Every star you have ever seen, every galaxy captured by the James Webb Space Telescope, every glowing nebula and swirling planet, is merely the white foam on the surface of a much deeper, much darker reality. For decades, we believed we were getting close to understanding the cosmos, only to realize that we have been looking at a mere 5% of existence. The rest is missing. It is invisible, untouchable, and utterly silent. Yet it acts as the gravitational glue that prevents the entire universe from flying apart at the seams. We call it dark matter. And it is the greatest unsolved mystery in the history of science. The story of how we discovered our own ignorance begins not with a telescope, but with a realization that the math simply didn't add up. In the 1,930 seconds, a brilliant and notoriously cantankerous astronomer named Fritz Zwicky was observing the Coma Cluster, a massive group of galaxies millions of light years away. Zwicky was measuring the speed at which these galaxies were moving, and what he found defied the laws of physics as they were understood. Based on the amount of visible light coming from the stars within those galaxies, there simply wasn't enough mass to generate the gravity needed to hold the cluster together. According to the calculations, the galaxies were moving so fast that they should have been flung out into the void, like children flying off a merry-go-round that is spinning 1,000 times too fast. Zwicky proposed that there must be some form of Dunkel materie dark matter providing the extra gravitational pull. His peers largely dismissed him as an eccentric, but decades later, the evidence became impossible to ignore. In the 1,970 seconds, Vera Rubin, a pioneering astronomer who had to fight for her place in a male-dominated field, looked at the rotation of individual spiral galaxies. She expected to see the stars at the edges of galaxies moving slower than the stars near the center, much like how the outer planets in our solar system crawl along compared to Mercury's frantic pace. Instead, she found something shocking. The stars at the very edge were moving just as fast as the stars in the middle. This meant that the galaxies were not just made of the glowing matter we see. They were embedded in massive, invisible halos of some substance that provided a colossal amount of extra gravity. Without this invisible scaffolding, the Milky Way would have unraveled billions of years ago. The stars we call home would be lonely wanderers in an empty abyss. Rubin's work confirmed that we weren't just missing a little bit of the universe, we were missing the vast majority of it. If dark matter doesn't emit, reflect, or absorb light, how can we be so sure it's actually there? The answer lies in how gravity bends the fabric of space-time itself. Albert Einstein taught us that mass curves space, much like a bowling ball sitting on a trampoline. When light from a distant star passes near a massive object, it follows that curve, creating an effect called gravitational lensing. When astronomers look deep into space, they see light being distorted and magnified in ways that visible galaxies alone cannot explain. We see ghostly rings and arcs of light that reveal the presence of massive clumps of dark matter lurking in the foreground. Perhaps the most smoking gun evidence is the Bullet Cluster, a cosmic collision between two massive groups of galaxies. While the hot gas of the galaxies slammed together and slowed down, the dark matter mapped through its gravity sailed right through the crash without stopping. This proved that dark matter isn't just a misunderstanding of gravity. It is a physical substance that doesn't interact with anything, not even itself. To understand the scale of this mystery, we must look at the inventory of the universe. Imagine the entire universe is a giant pizza. All the stars, planets, people, and atoms, everything we have ever touched or seen, make up only a single thin slice. That's 5%. Another 27% is dark matter. The remaining 68% is dark energy, an even more mysterious force pushing the universe apart. This means that 95% of the cosmos is made of things we don't understand and cannot see. Dark matter is the structural framework of the universe. In the early moments after the Big Bang, dark matter began to clump together under its own gravity. These clumps formed gravitational wells that acted like cosmic magnets, pulling in the ordinary hydrogen and helium gas that would eventually ignite into the first stars. Without dark matter to act as the architect, the gas would have stayed spread out too thinly, and galaxies as we know them would never have formed. But what is it made of? This is where the world of astronomy shakes hands with the world of particle physics. We know what dark matter is not. It isn't black holes, it isn't dead stars, and it isn't clouds of dust, because all of those things would interact with light or radiation in some detectable way. Instead, physicists believe dark matter is a new type of subatomic particle that has existed since the dawn of time. The leading candidate for decades has been the WIMP, or weakly interacting massive particle. These theoretical particles are thought to be heavy and slow-moving, ghosting through your body by the trillions every single second without hitting a single atom. Because they only interact through gravity and the weak nuclear force, they are nearly impossible to catch. Yet, catching them is exactly what we are trying to do in some of the most extreme environments on Earth. To find these ghosts, scientists have gone deep underground, turning abandoned gold mines and tunnels beneath mountains into high-tech traps. In places like the Sanford Underground Research Facility in South Dakota, the Lux Zeppelin experiment uses a massive tank filled with 7 tons of liquid xenon. The idea is simple, but incredibly difficult. They wait for a single dark matter particle to finally, by pure chance, bump into a xenon nucleus. If it does, it will create a tiny flash of light. To ensure they aren't seeing background noise from cosmic rays or radiation, they bury these detectors under miles of rock, which acts as a shield. For years, these detectors have been listening to the silence of the Earth, waiting for a signal that has yet to come. The lack of a discovery is starting to make some scientists nervous, suggesting that dark matter might be even stranger than the WIMP. Another major contender is the Axion, an incredibly light particle that was originally proposed to solve a completely different problem in nuclear physics. If dark matter is made of axions, it wouldn't behave like individual bullets, but more like a vast, vibrating field or a cosmic fluid that permeates the universe. Detecting axions requires entirely different technology, using powerful magnets to try and trick an axion into turning into a photon, a particle of light that we can actually see. At the same time, the Large Hadron Collider in Switzerland is smashing protons together at nearly the speed of light, hoping to recreate the high energy conditions of the Big Bang. The goal is to break the vacuum of space and produce a dark matter particle in the lab. If we see energy disappear during a collision, it could be the first time a human-made dark matter particle has escaped into the dark. While the hunt for the particle continues, some theorists are starting to wonder if we've been barking up the wrong tree entirely. A minority of scientists support a theory called MOND, or Modified Newtonian Dynamics. They suggest that we don't need an invisible substance to explain the universe. We just need to admit that our understanding of gravity is wrong. MOND proposes that on the scales of entire galaxies, gravity behaves differently than it does on Earth or in our solar system. However, while MOND explains galactic rotation well, it struggles to explain the larger structures of the universe or the evidence from the cosmic microwave background, the afterglow of the Big Bang. For now, most of the scientific community remains convinced that dark matter is a physical thing, a missing piece of the cosmic puzzle that simply hasn't been found yet. The stakes of this mystery are higher than they might seem. Dark matter is not just a curiosity, it is the architect of everything we know. In the early universe, dark matter clumped together first, creating gravitational wells that pulled in the ordinary gas and dust that eventually formed the first stars and galaxies. Without dark matter, the universe would likely be a thin, uniform soup of hydrogen gas, with no structures, no planets, and no life to observe it. We live in a dark matter universe where we are the minority occupants. Mapping the cosmic web, the vast, invisible filaments of dark matter that connect galaxies across the void, has become one of the primary missions of modern astrophysics. It is the skeletal system of the cosmos, and we are just the flesh. One of the most profound ways we visualize this invisible substance is through supercomputer simulations. Projects like the illustrious TNG or the Millennium Simulation have allowed scientists to hit play on the history of the universe. When they input only the matter we can see, the simulations fail miserably, galaxies don't form, stars fly away, and the universe looks nothing like our own. But when they add a massive amount of invisible, cold dark matter, the simulation blooms into a perfect replica of the night sky we see today. We see the emergence of the cosmic web, a complex network of dark matter threads that stretch across millions of light years. Galaxies are not just floating in empty space. They are like beads of dew on a massive, invisible spider web. This web provides the pathways for gas to flow into galaxies, fueling the birth of new stars for billions of years. The complexity of dark matter has led some to propose the dark sector theory. Just as ordinary matter isn't just one thing, it's made of quarks, leptons, gluons, and many other particles that create chemistry and life. Dark matter might also be a complex family of particles. There could be dark photons that carry a dark electromagnetic force, allowing dark matter particles to interact with each other in ways we can't perceive. There might be dark atoms or even dark stars that are totally invisible to our telescopes. This idea suggests that there is an entire shadow universe overlapping our own, a complex reality that we are simply blind to because we lack the right biological or technological eyes to see it. If this is true, our current search for a single type of particle might be like trying to understand the entire Earth by looking at one grain of sand. As we look toward the future, the search is only intensifying. New space telescopes like the European Space Agency's Euclid and NASA's Nancy Grace Roman Space Telescope are being launched specifically to map the dark side of the universe with unprecedented precision. These missions will look at billions of galaxies across 10 billion years of cosmic history, measuring how dark matter has shaped the expansion of the universe over time. By looking at how the lumpiness of dark matter has changed, they hope to determine if dark matter is truly cold and slow-moving, or if it has some warmth that prevents it from clumping too tightly. Every new data point brings us closer to a eureka moment that would redefine our place in the cosmos. Beyond the hard science, the mystery of dark matter carries a deep philosophical weight. It challenges our long-held belief that we are the center of the story. For centuries, humans thought Earth was the center of the universe. Then we learned we were just a planet orbiting a star. Then we realized our star was just one of billions in a galaxy. Then we realized our galaxy was just one of trillions. And now, we are faced with the most humbling realization of all. Even the very stuff we are made of, protons, neutrons, and electrons, is just a minor impurity in a universe made of something else entirely. We are the exceptions to the rule. We are the 5% of the universe that can see, think, and wonder about the other 95%. The search for dark matter is a testament to the power of human curiosity. We are a species that evolved on a tiny rock to survive by finding food and shelter, yet we have built machines that can detect the collision of invisible particles miles underground and telescopes that can see the curvature of space itself. We refuse to accept that there is a part of our world that is off limits. Even if dark matter remains hidden for another century, the quest to find it has already taught us more about the laws of physics, the birth of stars, and the fate of the universe than we ever could have imagined. We are learning to see with our minds what our eyes cannot perceive. What happens if we finally find it? The discovery of the dark matter particle would be the final piece of the standard model of physics, or perhaps the first piece of a new physics that goes beyond Einstein and quantum mechanics. It could unlock new ways of understanding gravity, perhaps even leading to technologies that sound like science fiction today. Just as our discovery of electromagnetism led to the light bulb, the internet, and the modern world, our discovery of the dark sector could open doors to forces we haven't even named yet. But even if it doesn't lead to a new gadget or a new engine, the discovery would provide something more important: the end of our cosmic blindness. We would finally be able to look at the night sky and see the whole picture. Imagine a future where we have mapped the dark matter currents as easily as we map the winds of the Atlantic. We would see the great rivers of invisible mass flowing between the galaxies, the massive halos protecting our home, and the silent scaffolding that holds every star in its place. We would no longer be looking at the white foam on the surface of the ocean. We would finally be diving into the depths. Until then, we continue to build our detectors, launch our satellites, and run our calculations. We continue to stare into the void, knowing that the void is not empty. It is full of the substance that made us, the substance that keeps us, and the substance that will eventually define the end of all things. As you look up at the stars tonight, remember that the darkness between them is not an absence of something, it is a presence. It is a vast, heavy, and silent ocean that carries us through the void. We are living in a ghost story, written in the language of gravity. The stars are beautiful, yes, but they are just the ornaments on a much larger, much grander structure. Dark matter is the ultimate reminder that the universe is far stranger, far larger, and far more connected than our five senses could ever lead us to believe. The hunt goes on, and the shadows are waiting to tell us their secrets. The experiments running right now, from the frozen depths of Antarctica to the vacuum of space, are the front lines of this battle for knowledge. In the IceCube Neutrino Observatory, scientists are using a cubic kilometer of clear Antarctic ice to look for signs of dark matter annihilating itself in the center of the Sunday. In the hills of Italy, the xenon experiment is pushing the boundaries of sensitivity to levels that were thought impossible a decade ago. Every day that we don't find a particle, the parameter space shrinks, forcing theorists to get more creative, more daring, and more radical. We are cornering the mystery, forcing it into a smaller and smaller room until it has nowhere left to hide. This journey into the dark is perhaps the most human thing we have ever done. It is a journey driven not by a need for profit or power, but by a fundamental need to know where we are. We are the universe trying to understand itself. Every time a scientist checks a data plot, every time a student learns about Rubin's curves, and every time a person looks at a picture of a gravitational lens and feels a sense of awe, the gap between the visible and the invisible closes just a little bit more. We are a part of the 5% that refuses to be ignored by the other 95. We are the light that is determined to illuminate the dark. In the end, dark matter is more than a particle or a gravitational anomaly. It is a symbol of the infinite horizon of human discovery. It tells us that no matter how much we think we know, there's always a deeper layer, a more profound truth, and a greater mystery waiting just out of sight. It invites us to be brave, to admit our ignorance, and to keep searching. The universe is holding its breath, waiting for us to solve the puzzle. And when we finally do, when we finally unmask the silent architect, we will find that the darkness was never something to be feared. It was the very thing that gave us a place to stand, a galaxy to call home, and a universe to explore. The invisible substance holding the universe together is no longer just a theory. It is a challenge. It is the final frontier of the map, the here be dragons of the cosmic age. But we have never been a species that stayed on the shore. We have always built ships, and now we are building them out of silicon, liquid xenon, and mathematics. We are sailing into the dark, and the wind at our backs is the gravity of 100 billion unseen worlds. The mystery is vast, the journey is long, but the destination is nothing less than the truth of existence itself. We are close, we are listening, and the universe is finally starting to speak back.